Welcome to this tutorial. I'm attempting question number 9 of O Level Physics GCSE uh, paper 2 to May-June exam series of 2018. This question is mainly related to the topic of the energy. The question says wind energy is renewable energy source. A wind turbine and generator convert energy in the wind to electrical energy in a generator. Figure 9.1 shows some wind turbines. So these are the wind turbines shown to us which convert wind energy into electrical energy with the help of the turbines. State what is meant by a renewable source of energy. It could be written as a source of energy which will not run out, or it is infinite. It is called a renewable source of energy. State the name of one other renewable energy source. So, solar energy is one other form of renewable energy that we can write here. The next part says some methods of generating electricity cause much more global warming than wind energy. State uh, one method of generating electricity that causes a large amount of global warming. So, one method which could be easily mentioned is burning of fossil fuel for generation of electricity. For example, if we are burning coal or oil or natural gas, etc., that would cause large amount of global warming. The next part says describe in outline how the method you have chosen causes a significant amount of global warming. So it produces carbon dioxide, or greenhouse gases, which trap energy and absorb infrared radiation and cause global warming. Okay. The next part says during a 30-minute period, a mass of 4.2 10 raised to 7 kilograms of air enters the turbine with a speed of 15 meters per second. Calculate the kinetic energy of the air that enters the turbine in 30 minutes. So we are given with mass here, and the speed of the wind is also given to us, and we have to calculate the kinetic energy in this part. So kinetic energy is given by the formula half mv square. So I am replacing the values. The mass would be replaced as 4.2 10 raised to 7, and the speed would be replaced as 15 square of the 15. So the answer we get for this part is 4.7 into 10 raised to 9 joules, and it is written in the standard form with two significant figures according to the requirement of the mark scheme. So in the answer space, I'm writing 4.7 into 10 raised to 9. The next part says the electrical power output of the generator connected to the turbine is 8.4 into 10 raised to 5 watt. So we are given with the electrical power output, which is 8.4 10 raised to 5 watt. calculate the electrical energy output from the turbine in 30 minutes. So for converting the electrical power output into electrical energy output, we would be using this formula, which says that energy is the product of power and time. Power is given to us as 8.4 10 raised to 5 watt, and time is given to be 30 minutes, which would be converted into seconds when we multiply it with 60. So the answer we get from this expression and multiplication is 1.5 10 raised to 9 joules. So this is the electrical energy output of the turbine. The next part says calculate the efficiency of the turbine and generator in converting the kinetic energy of the air to electrical energy. So in this part we have to calculate the efficiency of the turbine and the generator in converting the kinetic energy of the air to electrical energy. So the kinetic energy which we calculated would be the total energy input for the turbine and the generator, and the useful energy output is the one we just calculated in the previous part. So I am replacing it as 1.5 into 10 raised to 9, and the total energy input was 4.7 into 10 raised to 9. And since we are uh, giving our answer in the percentage form, so we would multiply it with 100 also. So we get the answer as 3.319 multiplied by 100%. If we convert it into two significant figures, the answer would be 32% for this part. So the efficiency of the turbine and the generator is 32%. The next part says the generator contains a coil that rotates between the poles of a magnet. The coil rotates 50 times in 1 second. So this information is useful and it can give us the frequency of the coils and produces an alternating voltage output with a maximum value of 500 volts. So this is the second piece of information, that it is producing an alternating voltage output and the maximum value for this output voltage is 500 volts. On the grid in figure 9.2, sketch a voltage time graph showing the output voltage. Since the coil rotates 50 times in 1 second, so it means that the frequency of the coil is 50 Hertz, which could be used to find the time period of this coil, and this would be 0.02 seconds. So one wave would be completed in 0.02 seconds. Now, for this graph, the graph would be starting here at 00, and the wave would be completed at 0.02 seconds, which means half of the wave would be completed at 0.01. So the first half should be shown as positive and the second half would be shown as negative, and this is how the one wave of this alternating voltage would be shown. And then if we continue the drawing, then the second wave would be shown on this graph too. So now I'm making this graph. First I'm making a point over here at the starting point, then the point at which the wave is completed, and then the point where half of the wave would be completed. I'm marking another point which would give the maximum positive value, another point which would give us the negative maximum value. Now I'm connecting these points. So this is how our graph would look like, which is drawn according to the given information. The next part says the output voltage from the generator is stepped up by a transformer. The electrical energy then passes along a transmission line to a distant house. Explain why a high voltage is used for the transmission of electrical energy. So a high voltage is used for the transmission of electrical energy because it reduces the current in the transmission lines or wires which causes lesser loss of useful energy. So to reduce the energy loss, we raise the voltage, and as a result, when the voltage is raised, the current reduces. A transformer is used to connect the transmission line to the house. So we use a step down transformer here. A step down transformer is used to bring the voltage to 240 volts because high voltage is dangerous for the household. So in the houses, the appliances need a value of voltage around 240 volts, and if the higher voltage is provided there, then it would cause damages there. So the question ends here with this part.
We try to explain complex concepts in simple language and with effective examples. If you like the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.